Welcome to This Explainer. We put it in our coffee, we bake it into cakes, but have you ever actually stopped to think about how a muddy, tough stalk of sugarcane turns into that perfect, sparkling white crystal?
It's genuinely a wild physical transformation. We're taking a dirty, fibrous plant and engineering it down to a geometrically perfect crystal. Today, we're going to trace every single step of that journey. By the end of this, you'll see a marvel of industrial efficiency that is practically hiding in plain sight.
All right, let's take a quick look at our roadmap. We've got 5 main steps: field to factory floor, extraction and sustaining power, purifying and boiling down, the magic of crystallization, and we'll wrap up with drying, grading, and shipping. Let's jump right in.
Starting with Section 1, Field to Factory Floor. Our virtual tour kicks off right at the factory gates. Thousands of tons of freshly harvested sugarcane arrive here every single day to get things started.
To really grasp the scale of the logistics here, just picture this sequence. First, every truck gets weighed at the gate. Then, before the cane even touches a production line, they meticulously sample it to test the sucrose content. Finally, these massive hydraulic cranes just effortlessly lift tons of raw material and drop it onto a relentless maze of moving conveyor belts.
Now, because this raw cane arrives straight out of the dirt, it's pretty covered in soil, so high-pressure water jets blast it clean. Once it's washed, the stalks pass through these brutal rotating knives and shredders. This actually doesn't extract the juice yet, it just aggressively rips the hard stalks into a fibrous mulch, perfectly prepping the whole batch for the mills.
Which brings us right to Section 2, extraction and sustaining power. And honestly, this is where the closed-loop engineering of this whole operation really starts to blow your mind.
That shredded, fibrous mulch gets forced through a sequence of heavy iron rollers. We are talking immense, punishing pressure here, literally squeezing out absolutely every possible drop of juice from the fiber.
Now, here's where it gets super interesting. The physical path of our material suddenly forks. On one side, the valuable, freshly squeezed juice rushes down the production line for processing. But what about all that crushed up, leftover dry fiber? I mean, you'd think it just goes to a landfill, right?
No way! That leftover fiber is called bagasse, and it is a total game changer. They divert it directly to the factory's power plant, where it's burned in boilers. This single byproduct generates all the high-pressure steam and electricity the entire massive facility needs to run. It's a perfectly self-sustaining loop, zero waste, massive energy savings. It's brilliant.
Okay, moving on to Section 3, purifying and boiling down. With the factory literally powering itself from its own waste, let's chase down that extracted raw juice. Right now it's highly acidic and frankly, full of suspended dirt. To clean it up, the juice gets heated and treated with something called milk of lime. It acts like absolute magic inside these giant settling ponds called clarifiers. The lime forces all those suspended impurities to sink straight to the bottom, leaving us with a perfectly clear, pale yellow juice that they just draw right off the top. But at this stage, that clear juice is still mostly water, so it flows through these towering tanks known as multiple effect evaporators. Over a couple of hours, the juice is boiled, but under a vacuum. This is a super clever trick to conserve energy because it lets the water evaporate at lower temperatures. As the water steams away, that thin, watery liquid transforms into a thick, concentrated golden syrup. All right, Section 4, the magic of crystallization. We are entering the absolute most technical stage of the entire factory. This is where the real physical transformation happens.
Think of this kind of like building a house. You need a foundation. Highly skilled technicians boiled that golden syrup until it hits supersaturation. Then, at the exact right moment, they seed it with microscopic sugar dust particles. Wandering sugar molecules latch onto these tiny anchors, and boom, they rapidly build up into the visible, geometric crystals we all recognize.
But here's the catch. You don't just instantly get dry sugar out of this. It creates this stuff called massacute, which is basically a thick industrial sludge. Our precious, perfectly formed sugar crystals are completely trapped inside this sticky, dark liquid molasses. So how do we rescue the sugar? High-speed centrifuges. These machines spin at mind-boggling speeds. The centrifugal G-force violently flings the liquid molasses right out through a fine mesh, essentially spinning it dry. And what's left behind? Safely trapped in the basket, pure white sugar crystals. Which brings us to our final stop, Section 5, drying, grading, and shipping. We're in the home stretch.
The sugar in that centrifuge basket looks great, but it's technically still wet and needs some final prep.
It's actually holding on to about 1% moisture. To fix this, it tumbles through giant rotary dryers. Blasts of hot, carefully filtered air strip away that final, lingering 1% of water. Then it's immediately cooled down. This is absolutely crucial, otherwise the crystals would turn into a giant rock-hard clump during storage. Now that we've got perfectly dry, free-flowing sugar, it cascades over a series of vibrating screens. Think of these like meticulous, giant sieves, automatically sorting the crystals by size into fine, medium, and coarse grades, just depending on what the final buyer needs. Finally, the sorted sugar funnels directly into high-speed automated bagging stations. Here, it gets precisely weighed and sealed into either massive industrial sacks for bakeries or those retail packets you grab off the grocery store shelf. And just like that, it's ready for global shipping.
It's really amazing, isn't it? A dirty, fibrous stalk becomes a flawless, pure white crystal, all while using its very own waste to power the entire transformation. It really forces you to step back and wonder what other incredible engineering secrets and perfectly closed loops are hiding behind the everyday products we totally take for granted. Thanks for exploring this with me today. Keep asking questions and keep looking closely at the world around you.